is the session DePIN Frontier, Redefining the Computing Power Landscape. DePIN is a crucial topic for 2024. Without further delay, let me introduce our speakers. Please welcome Jojo Theophile, Product Marketing Manager at Vivo Smart Chain. And next is Jose Hurry, co-founder of SES. Woo! And the next speaker is Daniel Wang, CEO and co-founder Acer. And moderating this session are IBC's technical advisor, Seth Cole. Woo! Thank you.
All right, good afternoon, everyone. So this panel is about DePIN. Just in case you don't know what DePIN is, it's a decentralized physical infrastructure. How many of you have heard about DePIN before? Can you raise hand? Oh, great. Yeah. So not only are we talking about DePIN, we're also going to talk about computing power. And I really can't think of any more trendy panel than this one. Without further ado, I'll let the speakers introduce themselves. So Dan, why don't you start? Oh, yeah, Jojo, you can start first. And also talk about your projects, of course.
Hi, I'm Jojo. I'm the head of product marketing at Vivo Smart Chain. Basically, what we are is a Layer 1 blockchain focused around giving users back control over their health data. So we manufacture devices like the one I'm wearing right here. These can connect to our blockchain, and basically these track similar things to what a Fitbit or Apple Watch would do. It's like health data, and every day you can upload your health data to our blockchain, and in exchange for that data, you're able to essentially receive our native token. So essentially, we're allowing people to monetize their health data every day just by existing and living life as they normally would.
Hi, my name is Joseph Lee. I'm a co-founder at SES. SES Network is a complete infrastructure based on blockchain technology. We build it into modules, including decentralized cloud storage and decentralized content delivery. Above that, we have an interface allow developer to develop the apps. The latest introduction that we have for SES is SES AI Gap to assist AI federated learning. So basically, our mission is to protect user data, ensure their privacy, giving the data value back to the user.
Hey everyone, Dan here. I'm the CEO and co-founder of Aether. We're a distributed cloud GPU network, primarily aimed at servicing real-time latency-sensitive use cases like cloud gaming, AI inferencing, and smartphone virtualization. We help bridge new and underutilized GPU compute with real-world demand. So,
Right. As we see, a DePIN can mean very different things in many different fields, right? Like we can have decentralized GPU network, we can have decentralized storage, we can have decentralized health data network, and also some of other example is decentralized car camera network, or decentralized mobile network like Helium, right? So I think with that said, like for each of the perspective area, what are the trends or constraints that you see in your domain? Yeah, Dan, do you want to talk first?
sure. Specifically for real-time compute, when it comes to like video processing, what we found was that centralized infrastructure always had a major constraint, and that was distance, right? The biggest function of performance and experience, but also cost, when it comes to like a cloud gaming service or voice to video AI inferencing experience is how far you are away from the point of service to your call to service, right? We all know cloud gaming scenarios. If the data center is in Singapore and you're playing in Indonesia, the ping is going to be super, super high, latency super bad, and just the overall experience really, really poor. So what we do is we utilize a distributed hardware network, similar to the way Helium has done it, or even like Ethereum mining back in the day, to incentivize compute contributors to onboard into the network, utilizing their existing compute to then bridge this gap at a local level with local demand for services. Versus the centralized model is to aggregate all compute into one giant data center for economies of scale, but then you suffer when it comes to performance and cost because of this centralization of GPU compute specifically. So that's kind of our approach.
Dan brought out a very good point about centralization. The centralization faced several issues. Scalability, failover, cost. How do we deal with that in a decentralized world? We will reduce the cost in decentralized world by putting into it a blockchain technology into our system. We have the failover built in. We have the capacity already there to grow with you, to scale better. So that's what our point of implementing the SaaS technology. The main purpose is to protect your data, making sure your data is private throughout our network. So let me just tell you, when the data comes into the SaaS network, we will make a default of 3 copies. With those 3 copies, we shard them. And with those sharded pieces, we encrypt each piece, distributed throughout our nodes globally. So in the case of you have a failure in any region or location, we are able to recover your data no matter where you are. So that's the best point of decentralization, is building to the technology without worrying about scalability, and the cost is reduced. Compared with Amazon AWS, we're about 1/10 the cost of that.
Yeah, he brings up a good point. Definitely the leading constraint, I would say, for centralized systems is definitely the infrastructure aspect to it. To successfully hold all the data, store it, and keep up with customer demand, you're constantly going to be needing new investments and new funding to build up these data centers to accurately and efficiently deal with all the data. On our end, we also, an aspect that's really important to us is data security. So since we personally are dealing with health data, we make sure to anonymize and encrypt everything that we do so that it can't be traced back to the user. In general, with what we're doing with health data, we've seen like an increase in need for normal, like healthy people's data as opposed to just the data. If, for example, if you go to the hospital or a doctor's office, normally you're going to for a checkup when you're not feeling well. But so the data is kind of skewed in that way where it's really towards unhealthy people. So there's been an increase in demand for data that is what a normal healthy person would have, for example. So what we're doing is essentially building up that network. We're able to leverage the technology that we all own today, like our phones and these devices, and essentially on the cost aspect compared to what a centralized solution would be, which would be, buying up all the data from all the different like service providers or data providers, and then storing that in an anonymized way. That would cost a ton of money and is not that scalable. With how we're doing it, we are essentially enabling people to be their own data provider in a sense, and have control over it while keeping the costs relatively low. So in the future, for whatever the data may be used for, the costs will maintain at a relatively low level compared to what a centralized solution may provide.
Cool. So it sounds like there are different aspects of pros about doing it the decentralized way, right? So cost, scalability, redundancy, yeah. So what about the cons for doing it the decentralized way? I know, like, usually, so for example, health data is very private. So privacy would probably be a concern, right? So what's your way, like, for each of you, like, what's the way that your solution deal with privacy? Yeah, Joseph.
Let me just start. Data privacy is very important, and it's one of the things that SES focuses on. Make sure we bring the data ownership back to the owner. So how do we do it? First, we have multiple layers of authentication, MFA, plus RBAC, role-based control. And once they get into our network, we have data integrity check. With the data integrity check, we have encryption. We will encrypt all the data. So there is one thing that user could do to allow other people to see their data is to authorize that user or group or whoever needs to see it, we could authorize that. And also our data can be compliant with government regulation. We have this new service called location-based storage selection, where user could select where the data stay within. For instance, in the US, if they don't let your data out of US, what are you going to do? We have this service called LBSS, where user can select to keep the data within US. So I think this is a very good point to keep the data privately and securely on our network.
One of the major constraints, I would say, or not major constraints, but one of the cons to DePIN is kind of also the benefit, which would be like the reliance on users, right? So if we don't have a lot of users that are contributing to the network or helping sustain it, then obviously the network won't be able to, succeed in the long term compared to a centralized solution, which if they have enough investment or funds to operate, regardless of how many users they have, they can keep it afloat. So the reliance on users is an aspect that is a pro and a con, but I think in terms of potential, since there are so many more people on the earth that have this technology available to contribute, if there's enough value proposition for them to take part in it, I would say that, there's not too much to worry about on that aspect.
Actually, I think I'll tack on to his point here around one of the other constraints or cons is the ensuring a minimum quality of experience. With DePIN inherently, you want to aggregate as much contribution from disparate, unique individuals as possible. But then how do you ensure that a minimum level of experience and standards are being met? I mean, if you're Amazon, it's all your own hardware. You can just make sure it's meeting the minimum contracted agreement with whatever customer. But if you're like Airbnb or Uber, how do you enforce that home or that car to meet all the standards required as expected by primarily enterprise clients? And it's very, very tough. So one of the things that we do pretty uniquely is we knew we could only get so far decentralizing or the compute side of things because we had to hold a very, very high bar for the type of compute that can be added to Aether's network. Unlike some of our other competitors out there, we actually don't allow random consumer-grade GPUs to contribute to Aether. And that's because if you contribute your gaming rig at home and you have a 4090, we can't stop you from using it. We can't stop you from turning it off anytime you want to. We can't stop you from watching Netflix and then your bandwidth chokes. But then how do we maintain a quality of service for our real clients like PUBG or Genshin Impact or China Mobile? And that's, so the way we do it is we only allow enterprise compute to come in. But the way we ensure that there's a high level of fidelity and quality in the overarching network is by decentralizing the server management and kind of auditing solution. So normally, this is all done in-house, right? Amazon just audits its own servers, and if anything is wrong or it's suffering from poor performance, it just pulls it offline. The way we do it is we had a node sale to sell licenses to operate as essentially checkers or auditors within our ecosystem. And really what they're running is server management software clients that are constantly pinging and auditing, checking on all the compute in our ecosystem to ensure that it's passing this minimum bar of service to meet consumer expectations, to meet our client demands. And that's one of the biggest cons is there's a struggle between how much you can decentralize versus how much you have to control in order to meet real world use case demands.
Now that's a very interesting point because, privacy, of course, and then, like quality of service is one of the biggest issue facing the DePIN ecosystem, right? So, Joseph, do you want to also give some thoughts on this? Like, how do you make sure in your network the quality of service, and how do you, basically rate the service provider?
Well, what does the quality of service mean to you? Is it performance? Is it low cost? Whatever it is, the SaaS network could give you both. So on our SaaS network, we will reduce the access time down to milliseconds or even lower to help you access the data quicker, faster, and ensure the data you receive is always available. So how do we do that? We have caching, we have indexing, and we'll access the data closest to the miner or the user who needs the data. So all that put together, we will provide the service the most efficient way.
Jojo, anything to share on that?
Well, in our specific use case, we are dealing with people's personal health data, right? So we have a duty to make sure that it isn't linked to them directly. So we don't want to have all identifying information linked to the data because that's kind of a breach of privacy, right? So we make sure to basically take all the data that people upload to our blockchain is anonymized and encrypted. So nothing is able to be traced back to the user, and that's something we, take pride in to make sure that their experience while using our platform and acting as a sort of data provider for us is a good one. Ensuring the privacy and making sure that they don't have anything to worry about on that end.
Great. So Dan, so it sounds like there's a balancing act on, permission. How many people do you want to allow in your network, and how you choose them, right? And is there a certain criteria that you have on that?
Yeah, that's a great question. So in the infancy of our network, we actually have to hold the bar super, super high to maintain an aggregate average quality of service that is essentially meeting the Six Sigma of uptime requirements demanded by our clients. But as the network grows and the onboarding and offboarding or potential downtime of any one individual compute contributor starts to decrease, we can start to lower the minimum barrier requirements necessary to contribute compute. For example, right now, we probably have a dozen or so major compute contributors. These are some of the largest infrastructure providers in the world, some of the largest telcos, some of the largest mining groups like Bitmain and Bitdeer, they all contribute compute and GPU compute into our ecosystem. The end state we'd like to get to is what Render or Akash is doing, is to allow individuals to contribute compute personally into the network. But to be able to do that, we have to ensure that there's enough redundancy, that there's enough stability and resiliency in the network, such that if any single one of them does decide to offboard, we have a fail-safe, we have spillover ready to pick up that slack, so that there's very little to no interruption of service for our actual enterprise customers. And that just takes time. I think we're 4 to 3 weeks post-token launch. We're still in phase 2 of our test net. So our main net for all of our IDC and edge compute hasn't started. But we do have in the roadmap, probably 12 to 18 months in, the ability to start accepting certain levels of consumer compute in controlled environments and in specific batches for specific use cases that are generally a little bit less demanding. And then we can route that work, assign or index that work specifically to this type of compute so that there's less risk to the overall ecosystem. Because remember, in our network, the compute contributor has to stake. They have to stake ATH tokens in order to contribute compute, such that if there is downtime, there is something to slash and compensate the customer with. So it's a time thing. We know we're starting in a very somewhat more centralized manner with really, really high barrier of entry, but we expect to be able to lower that over time as the network grows.
Joseph, do you want to share a little bit on how you guys think about quality of service? What would be the minimum threshold to to stay stay on the network, being a provider?
Data availability is always very important. So that's why our protocol within our network to ensure the data is always available without losing your data, that would be a very important part. So we do also have storage miners. They are the resource contributor on our network. Like what Dan said, they also have to stake. So with their staking, we want to ensure they are quality miners. We want to make sure the storage capacity is there. What we say there is there. We have another protocol called the proof of idle space to make sure the space they offer is for real. So we're not just looking at the space available, we actually write to those empty space, calculate the numbers, make sure that it's a number what they say. So that we could make sure what we offer on our space is accurate. So our network is still in testnet phase. We've been testing this for the past 5 years. We will launch to the mainnet before the end of this year. So we're ready. Our technology is very mature, and we're ready for the world.
Jojo, you want to talk about in your network, what would be the minimum qualification, I guess, to be a service provider?
Yeah. So in terms of data quality or ensuring the quality of the data that's uploaded to the network, we have in our devices a protocol called proof of sensing. So we don't want people to just wave a device or to act like they're being active or something like that. We have sensors within the devices that track your heart rate, breath rate, all these different health metrics to ensure that you are actually a live human and not a bot trying to create false data to mess up the quality of the data that's on the network. So yeah, within all of our devices, we've basically input these. It's think of it like a consensus protocol within the device to ensure that the data that is being uploaded and tracked is actually of quality and not some garbage data or a bad reading or something like that. So all of it is done within the devices that we have, and that's essentially how we ensure the quality of the data that's being uploaded to the blockchain is, you know, ensuring that it's high quality and not like easily replicated or faked.
Okay, cool. Great. So with the last 5 minutes that we have, I kind of want to go to some predictions. So with each of the area that you're in, can you give us some prediction in terms of like centralized solution versus decentralized solution and how this thing grows? Yeah. Anyone want to take the shot first?
Well, I'm a pretty firm believer in like a Ready Player One future state of the world. I think that the difference between that future state and now is primarily everything there is up in the cloud, right? If you think about the movie, they throw on a pair of goggles and instantly they're in some virtualized world. But they're not carrying around a giant backpack or a computer or something powering, some physical piece of hardware powering their entire virtual experience. All that compute power is done up in the cloud. All of that storage is done up in the cloud, right? All the rendering, everything that's done on the fly, all up in the cloud. Now, how do we get there? Well, it's primarily about access. If you think about 15, 20 years ago, internet penetration was still relatively quite low because, well, we didn't have these yet, right? You had to log on to a PC, go to a library to access the internet via dial-up. But the moment you lowered hardware barriers to that of like a smartphone, internet penetration went up 6-7-fold to just over, I think, 6 billion individuals on the planet. And I truly believe it's the same thing with just virtual worlds and virtual content. Once you remove hardware barriers by moving everything into the cloud, and you remove hardware as a variable or a function of being able to access content, we'll be able to move forward very quickly into this kind of future state. And there's only one way this can happen. It has to happen in a decentralized manner so that the collective resources of all communities can contribute into that future state.
Very good point, Dan. I think going forward in the future, you cannot predict the future, but we are seeing the trend in the market, how we require the compute power and the GPU power. But let's talk about the fundamental. Data is always going to be there. How do we store them? How do we make them secure? How do we ensure the data is always available to go forward to allow those fast compute power to process them? So our infrastructure is there to do that for you. We will grow with your need, and we scale with your need. And I also like to mention, CES has applied to IEEE for the blockchain decentralized protocol specification. They have accepted that application, and we will go forward with the standardization. So the future is endless, it's bright. The demand for compute and GPU power is always going to be there. And CES is going to be right there with them.
Yeah, I pretty much agree with what they're both saying. I also think the potential for like DePIN and the need for like data storage and tracking of data properly will only continue to increase with like as we continue to use all these different like devices, whether it be like a smartwatch or a phone or anything like that. All the data is, you know, as companies see the value within it, the demand for it will continue to increase, and as users also become more aware of how like data security is important to them and how it affects them, I think you know, the use cases for DePIN will, you know, continue to rise over the coming years as well.
All right, great. So I think we're right on time. So if you have more questions, feel free to, you know, grab any of them off stage. So thank you all for listening.
Thank you. Thank you very much. Thank you very much.